Good morning everyone, I hope we are well. In today's lesson we're going to be continuing our volume unit, today focusing on how to calculate the volume of a prism. Before I tell you how to calculate the volume of a prism, we first need to know what a prism actually is. So, a prism is just a 3D shape that has a constant cross-section across its length. Cross-section, you may not have heard this word before, so let me explain what cross-section actually means. So for this triangular prism, we would say that it has a triangular cross-section. And by cross-section, I mean it's almost like a slice of the shape. So if you look at this 3D shape here, no matter where I slice this shape, it's always going to have that triangular face. So that triangular face is called the cross-section. Can you think, what would the cross-section of this prism look like? So the cross-section of this prism, it would look something like this. Well, exactly like this. It's a pentagon, right? And no matter where I cross that prism along its length, I will always have a pentagon of the same size. So a prism is a shape where no matter where I cut that shape, I'm always going to get the same cross-section with the same size as well. So have a look at these two shapes. Would you say that these are prisms? So pause the video to think about it. I want you to tell me, are these prisms or not? Okay, so this first one, I'm going to tell you, well, yes, it is a prism. I know it's a prism because it has a constant cross-section. So I've got this octagon here, and no matter where I chop this shape, I'm always going to have that same octagon. So similarly, on this next shape, so I have this L shape as my cross-section, and no matter where I cut the shape, that slice is always going to look like an L shape. Is this a prism? So pause the video to think about it and you tell me if this is a prism or not. Okay, so with this shape, the cross-section, it's a circle, right? And no matter where I chop this shape, it is a circle. However, this is not a prism. Why not? Well, it's not a prism because that circle is a different size. If you chop it on the end, it's quite a small circle, but if you chop the shape in the middle, so this sphere in the middle, it's going to be a larger circle. So it's only a prism when that shape is the same size all the way through. A Toblerone bar. Would you say that the box of a Toblerone is a prism? Well, I'm going to tell you, yes, it is a prism because it has a consistent cross-section. It's a triangle all the way through. Next shape. A pyramid. Would you say that a pyramid is a type of prism? Well, let's think about it. If I take my pyramid, if I slice it horizontally this way, okay, so it's a square. If I slice it here, it's a square. If I slice it here, it's a square, and so on. So it's always a square. So is this shape a prism? I'm going to tell you, no, it's not. It's not a prism because the square is not the same size all the way through. Okay, last one. Would you say that this shape is a prism? Okay, so this pencil, I'm going to tell you, it's not a prism. It's not a prism because it doesn't have that consistent cross-section. However, what could you do to this pencil to turn it into a prism? So pause the video if you need some time to think. What would you need to do to this pencil to make it a prism? Well, if you chop this pencil twice, so if I got a saw and chopped it here and here, so get rid of that pointy end and the metal bit and the rubber, I would have a prism. So I'm not quite sure what type of prism. It might be an octagonal prism, something like that, but I would definitely have a prism if I chopped it there. Okay, so let's just try a couple of questions together just to make sure we understand what the cross-section actually is. Well, what the cross-section of this first shape look like? Well, the cross-section I'm shading like this. So the cross-section is this trapezium face. And what does the depth mean? Well, depth is just the length that face is perfectly perpendicular away from the cross-section. So in this shape, this would be the depth. That's not the only correct answer. For example, if you see where I'm wiggling my cursor, either this length or this length, they're also the depth. So the depth just means how far back it goes from the cross-section. Okay, next shape along. Can you think what the cross-section would look like for this shape? Okay, so here is my cross-section. So it's a five-sided shape, so it's a pentagon. And then my depth is just any one of those lengths facing perfectly perpendicular from that cross-section. Okay, so pause the video if you need some more time to think about the last three, and then I'm going to reveal all three of those answers at once. Okay, so here are your cross sections and depths. Okay, so today we're going to be learning how to calculate the volume of a prism. Thankfully, there's quite an easy formula to use to calculate this. All we need to do is find the area of our cross section and multiply it by the depth. So let me give you a couple of examples. And before we move on, it's very important that you make a note of this formula. You need to remember it off by heart, so make sure we write it down. Okay, so area of cross section times by the depth. That's how we find the volume of a prism. So here's my first prism. In this question, they actually tell us that the area of this cross section is 12. So all I'm going to do is do 12 multiplied by 7, and then my final answer is 84 centimeter cubed. That is the volume of that prism. Next question. If you're feeling confident, please can you pause the video and try and find the volume of this shape, or if you're not sure, just leave the video running because I'm going to explain it now. So let's find the volume of this prism. To find the volume of a prism, we know that we find the area of the cross section and times it by the depth. Do we have these pieces of information? Well, I'm going to tell you we do have the depth. The depth is 14, but at the moment they haven't given us the area of the cross section. The cross section is this triangular face, but we need to work out the area. So in that first question they gave us the area. In this question, that's alright, we can work it out. We know how to find the area of a triangle. So the area of a triangle is base times height and then half it. I'm doing 5 times by 8 and then I'm dividing it by 2. So the area of the triangle is 20 centimeters squared. Now that I have the area of my cross section, I need to do 20 times by the depth, and the depth is 14. So 20 times by 14, that tells me that my final volume is 280 centimeters cubed, and I have solved the problem. Alright, so please can you find your classwork for today attached for you on Google Classroom. All your solutions are on there, and just please let me know if you would like any help with that. Alright, thanks very much guys.